Hello dear students, I hope you are doing well and keeping safe at home. So this is our last part, that is the exercise 6.5, and remember that this is the most important part of your application of derivatives because this part used to carry a huge sum of marks in your final exams. So please go through the previous videos first, that is the theory of this maximum minima, and then come to the problems. So let us see the first one here that we have taken, that is number 1, fx is equal to 9x squared plus 12x plus 2. So we need to check whether this function has a local maximum, whether this function has a maximum value or a minimum value, and what is the point. So here the given function is f of x is equal to 9x squared plus 12x plus 2. So I can write it as 3x whole square plus 2 into 3x plus into 2 is 612 here, plus I can write it as 2 square minus 2. So both are same, isn't it? 2 square will be 4, 4 minus 2 is 2. Now this together can be written as thrice x plus 2 whole square minus 2. So I have changed my function from here to here. Now let us see whether this function attains a maximum value or a minimum value, and where does it attain. So for that, how to do it? Just check it. We know that 3x plus 2 whole square, since it is a whole square, whatever value is inside this, it will be always either equal to 0 or greater than 0, isn't it? So if I add 3x plus 2 whole square, if I subtract a minus 2 here, so I shall be subtracting minus 2 on both sides, isn't it? So this means f of x is greater than equals to minus 2. Fine. Okay. So what we can see that f of x, this is the minimum. F of x, all the values of f of x is greater than equal to minus 2. So here minus 2 is the minimum value. Fine. So at what point minus 2 is the minimum? So therefore f has minimum, or f is minimum at the point. So for which point, if I put x equal to, it will be minus 2 here. That means I want to make this part 0. So if I want to make this part 0, so what if we put here? Just see that it will be 3x plus 2 is equal to 0 when we shall have x is equal to minus 2 by 3. So here x will be equal to minus 2 by 3. So f is minimum at the point x equal to minus 2 by 3, and the minimum value is f of minus 2 by 3, and that is what? For minus 2 by 3 will be 3 into minus 2 by 3 plus 2 whole square minus 2, and that will be equal to minus 2. So we have got the minimum value. Fine. Now let us see another problem, that is question number 3, Roman 4. Here the function is given fx is equal to sin x minus cos x. So we need to find, or we need to check that whether this function has a local maxima or local minima, and where does this function has the local minima, or what is the value of the local maxima or local minima. So let us see. Here fx is equal to sin x minus cos x. So let us write this, fx is equal to sin x minus cos x. Therefore what we need to find? F dash x. So for f dash x will be cos x minus or plus sin x. Okay. So how to find the local maxima and local minima? We can find it either by first derivative test or by second derivative test. So what is the second derivative test? At first find the f dash x, then find the critical points, and then find the f double dash x, and if f double dash x is less than 0, we shall have the maximum, local maximum, and if f double dash x is greater than 0, we shall have the local minimum. So here f dash x and our f double dash x will be minus of sin x plus cos x. Now what to do? equate the f dash x is equal to 0 so that we get the critical points. So this will imply cos x plus sin x is equal to 0, and from there we shall get cos x is equal to minus of sin x, and this will imply minus 1 is equal to tan x, and from there I can write minus 1 means tan of pi by 4 is 1, so I shall write it as tan x. So since there is a negative, I can take tan of pi minus pi by 4, this will be equal to tan x, and hence I get tan of, this will be 4 pi 3 pi by 4 is equal to tan x, and thus we are getting the value of x is 3 pi by 4. So this is our critical point. That means we can say that at this particular point, if we check the f double dash x, whether it will be either it will be less than 0 or greater than 0. Therefore f double dash x at the point 3 pi by 4 will give us what? It is minus of sine 3 pi by 4. Okay, let me write it here. F double dash at the point 3 pi by 4. So this will be minus sine 3 pi by 4 plus cos 3 pi by 4. Now this can be written as minus of sine 3 pi by 4 means pi minus pi by 4 plus cos of pi minus pi by 4. Now this is equal to minus of sine. What is pi minus pi by 4? Because it's in the first second quadrant, so all sine is positive, so it will be pi by 4, and here all sines it is negative, so it will be cos of pi by 4 minus cos of pi by 4. So thus we have got the value, and what is sine of pi by 4? It is 1 by root 2, and cos of pi by 4 is, it will be minus 1 by root 2, and this will also be minus 1 by root 2. So if we add this, it will be minus 2 by root 2. So clearly this value is less than 0. Since this value is less than 0, therefore we can say that f has a maximum value, since it is less than 0, maximum value at x is equal to 3 pi by 4. So you have got the maximum value at this point. Now what is the maximum value? Or just write f is a local maximum value. So what is the local maximum value here? Therefore the local maximum value of f at x is equal to 3 pi by 4 is given by f of 3 pi by 4, and that is equal to sine of 3 pi by 4 minus cos of 3 pi by 4, and that is equal to, I can write 3 pi by 4 as pi minus pi by 4, and 3 pi by 4 here is pi minus pi by 4, which in turn will give us sine of pi by 4 because it lies in the second quadrant. So this will be sine of pi by 4 minus, this also lies in the second quadrant, so it will be negative will be positive. So sine pi by 4 is 1 by root 2 plus cos pi by 4 is 1 by root 2, so this will give us 2 by root 2, and hence we are getting root 2 here. So this is the local maximum value of the function f at the point 3 pi by 4. Easy. So this is how we find the local maximum and local minimum. Let us see another problem, that is question number 5. Here we need to find the absolute maximum value and the absolute minimum value, where in this interval. So one thing you should notice is that whenever such type of questions is given, that is for absolute maximum, absolute minimum, the interval is always given closed. That means you will definitely find a maximum or minimum value. Okay, so how to do? At first write the function, that is fx is equal to 4x minus 1 by 2 x square. Therefore our f dash x will be 4 minus 1 by 2 2x, and that will be 4 minus x. Fine. Now equate the first derivative to 0. So if we take f dash x is equal to 0, we shall get 4 minus x is equal to 0, and from here we shall get x is equal to 4. So x is equal to 4 is the critical point. Okay, now what to do? Find f of 4, that is find the value of f at the point 4, x is equal to 4, and at the end points, that is at the critical point and at the end points. And what are the end points? -2 and 9/2. So you have to find the function at all these 3 points, and let us see what happens. At f is equal to, at x is equal to 4, that is f of 4, we shall have 4 into 4 minus 1/2, 4 square, so it will be 16, this will be 8, and f of -2 will be 4 minus 2, this will be -2, here it will be -8 and minus 1/2, 4, so -10, and for f of 9/2 we shall have 4 9/2 minus 1/2, 9/2 whole square, so this will be 18, and here it will be 1/2, 81/4, so this will be 18 minus 8, 81. So if you calculate it, it will be 8 6 8 128 minus 81, so it will be something 43 8. So it is something 5 point something, so definitely greater than, less than 8 and greater than -10, isn't it? So therefore the absolute maximum will be what? The absolute maximum will be 8, because this is the greatest number of out of all these 3. So absolute maximum value is 8, where at the point x is equal to 4, and absolute minimum value is where at the point, and absolute minimum value is -10 at the point where x is equal to -2. So this is how we find the absolute maximum and absolute minimum for a given function. So next we have question number 10. Here it is given, find the maximum value of twice x cube minus 24x plus 107 in the closed interval 1 3. So here the interval given is 1 3. So, and since it is given that find the maximum value, so in the closed interval the maximum value and the absolute maximum value both are same. So our focus will be to find the absolute maximum value at this interval. So here the function given is, let f of x is equal to twice x cube minus 24x plus 107. So our first derivative will be 6x square minus 24, and which in turn can be written as x square minus 4. Okay, now what to do? Equate the first difference or first derivative to 0 to find the critical points. Now f dash is equal to 0 will imply 6 into x square minus 4 is equal to 0, and from there we get x square minus 4 is equal to 0, which in turn will give us x equal to plus minus 2. Thus we have got two critical points at which we need to check the maximum and minimum value. Now one thing you see that here we have got two values, there is plus 2 and minus 2, but minus 2 does not belong to the but minus 2 does not belong in the interval 1 3. Okay, so we need to consider only the plus 2. We need to check the critical, or we need to check the maximum and minima at this point. And since it is a closed interval, so we need to consider the end points also, that is 1 3, and from there we shall get the absolute maximum and the absolute minimum value. So for that, let us check at x is equal to 1 first. F of 1 will give us, what is f of 1? It is 2 into x cube minus 24 into 1 plus 107, and that will be equal to 2 minus 24 plus 107, so that will be equal to 109 minus 24, so 5 and 10 minus 2, it is 85. And second, at x is equal to 2, we shall have, that is at this point, f of 2 is equal to 2 into 2 cube minus 24 into 2 plus 107. So this will give us 2 cube is 8, 16 minus 48 plus 107. So this will give us how much? 107, 13 to 123 minus 48, so that will be 75. And at x is equal to, we need to check at the point 3, f of 3 will be 2 into 3 cube minus 24 into 3 plus 107. So that will give us 2 into 27 minus 24 into 3, that is for the 12, 1, 2, 3 to 6, 72 plus 107. So that will give us, I've written it, 89. Fine. So these are the three values that we have got. Now what is the maximum value here? It is 89. And what is the minimum value? It is 75. Fine. So at x equal to 3, we get the absolute maximum, and at x equal to 2, that is f2, we get the absolute minimum, that is 75. Fine. So this the maximum and minimum we have got in the interval 1, 3. You try to do for minus 3 and 1. In this case, what will happen? We have to consider the minus 2 also. Fine. So that is the difference. Let us see question number 14. Here, find the two positive numbers x and y such that this condition holds, that is x plus y equal to 60, and xy cube is maximum, that is our function is this, and we have to maximize this. So how to do? Here the first equation is given x plus y equal to 60, so from there we can write x is equal to, y is equal to 60 minus x. Okay, so let it be 1. Let us consider this function as fx is equal to x into y cube. So in place of y, replace it by 60 minus x, or you can directly write this also. So this will be a function of x itself. So this cube from here. Fine. So thus we have got our x cube, f of x. Now if we want to maximize this function, or if we want to find the maximum value, then what to do? Take the first derivative of this and find the critical points. After that, take the second derivative and check the critical points at those second derivative, and check the less than greater than, and then you will get the values. So to the first derivative, it will be 3 first function, second function. So keep it 60 minus x cube first function plus second function will be 3 into 60 minus x whole square into x. And since it is a negative here, so you need to write a negative. So this is our f dash x. From there, what I can do, I can take 60 minus x whole square common. So I shall be remaining with 60 minus x minus thrice x. So this will give us 60 minus x whole square, and here we shall have 60 minus 4x. Fine. Then let us find the second derivative. It will be first function, second function. So first function to differentiate second function, so it will be minus 4 here, and plus 60 minus 4x into 2 into 60 minus x and into minus 1 here. Now take 60 minus x common from both sides, we can do it. So it will be minus 4 into 60 minus x minus 60 minus 4x into 2. So this will give us 60 minus x into 6. Here it will be 24 plus 4x minus 120 plus 8x. This will give us 60 minus x into, so 240 minus it is a minus again, so it will be minus 4 to 6 360 plus 12x. Fine. Now if I take the 12 out, I shall have 60 minus x into x minus 30. So we have got f double dash x is equal to this. So after this, what we do, we take the first or equate the first derivative equal to 0 to find the critical points. So let us do that. Let f dash x is equal to 0. So this will imply what? 60 minus x whole square into 60 minus 4x equal to 0. So from there what we shall get? Let us see. We have two options, that is, one is 60 minus x whole square is equal to 0 or 60 minus 4x is equal to 0. So this will imply x is equal to 60, and from here we shall get x is equal to 15. So thus we have got 2 points or 2 critical points, and now we need to check in which of the points our f dash x is less than 0 greater than 0. Since it is we need to find the maximum, so we must get at which points f double dash x is less than 0. Okay. Now f double dash at the point 60, let us check it. So this will be, if I put here 60 minus 60 will be 0, and this is x minus 60 minus 30. So this will be clearly 0, isn't it? Since f double dash x at the point 60 is 0, so it is the test fails here. That is, we cannot find the critical we cannot find the maximum or minimum values. Now let us check at the point x equal to 15. What about this? It is 12 into, so in place of here we have 60, sorry, it will be 60 minus, in place of x 15, and here 15 minus 30. So this will give us 12 into 16 minus 15 will be 45, and 15 minus 30 will be minus 15. So this is a negative value, isn't it? Because a negative sign is there, so multiplying it will be negative value, and since it is negative, so it will be less than 0. Therefore we have got that f double dash x at the point 15 is less than 0, and thus at the point 15 we get the maximum value of the function fx. Fine. So that will be the answer. So after this, what we do, we take the first or equate the first derivative equal to 0 to find the critical points. So let us do that. Let f dash x is equal to 0. So this will imply what? 60 minus x whole square into 60 minus 4x equal to 0. So from there what we shall get? Let us see. We have two options, that is, one is 60 minus x whole square is equal to 0 or 60 minus 4x is equal to 0. So this will imply x is equal to 60, and from here we shall get x is equal to 15. So thus we have got 2 points or 2 critical points, and now we need to check in which of the points our f dash x is less than 0 greater than 0. Since it is we need to find the maximum, so we must get at which points f double dash x is less than 0. Okay. Now f double dash at the point 60, let us check it. So this will be, if I put here 60 minus 60 will be 0, and this is x minus 60 minus 30. So this will be clearly 0, isn't it? Since f double dash x at the point 60 is 0, so it is the test fails here. That is, we cannot find the critical we cannot find the maximum or minimum values. Now let us check at the point x equal to 15. What about this? It is 12 into, so in place of here we have 60, sorry, it will be 60 minus, in place of x 15, and here 15 minus 30. So this will give us 12 into 16 minus 15 will be 45, and 15 minus 30 will be minus 15. So this is a negative value, isn't it? Because a negative sign is there, so multiplying it will be negative value, and since it is negative, so it will be less than 0. Therefore we have got that f double dash x at the point 15 is less than 0, and thus at the point 15 we get the maximum value of the function fx. Fine. So that will be the answer. So this will be the end of this video, and in the next video we shall come up with 2 or 3 more important problems, the lengthy one of exercise 6.5. So till then, practice all the problems and the examples given, and stay home and stay safe. Thank you.